Welcome participants. Good afternoon to all the participants. We are now in the lecture 3 of this GAN course. In this session, we are going to talk about emission control device, PCV valve, air pump, evaporative emission canister, these three topics. So myself, Dr. Biplab Kumar Devnath from the Department of Mechanical Engineering, National Institute of Technology, Meghalaya. There are different types of emission control devices available in IC engines. Out of them, these five are the primary emission control devices. Number one is positive crankcase ventilation. Second is evaporative emission control. Third, air pump. Fourth, exhaust gas recirculation. And fifth, catalytic converter. Now, in this particular lecture, I'm going to cover the positive crankcase ventilation, evaporative emission control, and air pump. Exhaust gas recirculation and catalytic converter will be covered by Professor Yang Eun Min in his proceeding lectures. Now, as you can see in this particular diagram, it's an internal combustion engine, either SI or CI, any one of them. In this particular picture, we can see there is a piston and there is a cylinder one. Now, piston and cylinder one necessarily cannot be in touch with each other directly because it will create huge amount of friction if we do so, and it will deteriorate the life of the engine. So how actually piston moves up and down in the cylinder? It is done with the help of three piston rings, as you can see over here. These piston rings guides the piston to move up and down inside the cylinder. And in between this, between the piston and the cylinder, there will be a very small gap ranging between 0.025 to 0.05 mm of gap. So this much very small gap has been kept between the piston and the cylinder to safeguard their life. So as you can see, because of this gap, this piston and cylinder does not lock each other. So in between this, there will be a very thin layer of lubricating oil, which will lubricate the surfaces of piston and the cylinder. Not only lubricate, they also act as a cooling medium and also try to seal the gap. Why I am mentioning try to seal the gap? Because the lubricating oil is a liquid type. Being liquid in nature, the lubricating oil cannot 100% leak proof the piston and the cylinder. So there will be certain porous regions through which any gaseous material can pass through it. Now, when we perform IC engine operation, if I talk about a 4-stroke engine, then there will be suction, compression, power, and exhaust. Apart from suction stroke, all other stroke like compression, power, and exhaust, the inside the combustion chamber, the zone is highly pressurized. So because of this high pressure, the gases can leak through this particular porous layer as I was discussing and come into the crankcase. There are three possibilities of gases which can come through this zone. Possibility number one, only air can come. When only air can come if it is an diesel engine or CI engine. So for CI engine, only air can pass through this when there is a compression stroke going on. Apart from air, there can be mixture of air plus fuel, definitely the vapor fuel, which will which can come through this gap between the piston and cylinder and come to the crankcase. The third case, which is the most uh, common case or most considerable case, it's basically the incompletely burned mixture of gas and fuel, primarily hydrocarbon, okay, which may leak through this along with certain amount of exhaust. Okay, certain amount of exhaust can leak through it. Okay, so the uh, leakage of hydrocarbon and exhaust is found to be higher. The chances of leakage of this is much higher because at this time the gas inside the cylinder remains at a very high pressure. We know that in case of diesel engine, the pressure inside the combustion chamber ranges within 30 to around 100 bar. Okay, so much high pressure, although it remains for a very short duration, but pressure reaches at this particular level. So at this particular level, there are more likelihood of the leaking of the hydrocarbon in incompletely burned gases through this piston cylinder gap and coming inside this crank case. This is called as crank case. Okay. So when this hydrocarbon and incompletely burned fuel comes into the crankcase, it can create primarily again three type of problems. Okay, first problem is that when these gases continuously come and store inside the crankcase, this, by the way, this crankcase is sealed. Okay, this crankcase is completely sealed, so it will pressurize the crankcase, and at a certain point will come where it may rupture the crankcase and create leakage of lubricating oil. Okay, leakage problem can arise. Okay, so this is first problem. Second problem is that because of this hydrocarbon, okay, coming during the stroke, okay, especially the combustion stroke and the exhaust stroke, the gases will be coming here. They come at a high temperature. Okay, so temperature of this gas will be higher. At this high temperature, these gases, firstly, they evaporate the lubricating oil, lube oil, which has been stored in the crankcase. First problem. Second problem is that they react with the lubricating oil, forms corrosive acids and sludges. Okay, so you cannot allow the exhaust gases to store here. Okay, by the way, this leaking is known as blow by. Blow by. So because of this blow by, first problem is that it can create leakage problem, and it can evaporate the lubricating oil because they come at high temperature, and also they reacts, corrodes the lubricating oil, creates acid and sludge, which is detrimental for the life of the engine concerned. Okay, now you can tell, sir, okay, I understood two problems. Why don't you just create a uh, gap or create a hole through this or a vent in the engine cylinder and allow this gas to throw in the atmosphere? Yes, definitely we can do. In fact, this was the process which earlier people used to do. Old engine used to have a vent over here through which these gases can go out to the atmosphere. But as days pass by, we are more concerned about the environment, and these gases, which are predominantly the hydrocarbon and the exhaust, incompletely burned gas, when they release into the atmosphere, they create environmental pollution. Environmental pollution. Okay, so these three are the major problem because of the presence of blow by, which will definitely will be there because you cannot make this piston and the cylinder 100% leak proof. Okay, so what is the solution? The solution can be, one primary solution is very easy. You can tell that, sir, why don't you link this crankcase along with the piston inside the combustion chamber? Then these gases can go into the combustion chamber and burn out. I'll tell that, yes, very good. This is a good, valid option. Okay. Definitely we can create a vent over here. Okay. And link it into the piston inside the combustion chamber so that this gas can go and inside the combustion chamber and burn it out. But the problem is that when the combustion occurs, as I told, inside the combustion chamber, the pressure is very high. So at a very high pressure, this gas again can come back into the crankcase and create some of these three problems. So linking the crankcase directly inside the combustion chamber is not viable. Okay. So then what is the solution? The solution is, which is currently nowadays being used. This is called as positive crankcase ventilation, and connecting this particular crankcase line into the intake manifold. Okay, intake manifold. So connect the crankcase with the help of a pipe into the intake manifold. Okay, so that is basically the solution, and that we are going to discuss in the next slide. So as you can see in the next slide, that's a colored pipe, as you can see over here. So this side, from this side, we collect this crankcase exhaust, okay, through a valve, okay, which is known as PCV valve. I will explain it, PCV valve, after some time. So PCV valve is used over here. Through this PCV valve, the exhaust gas passes through this particular hose. There may be a small air filter over here, from where it is again connected to the intake manifold. Now, why intake manifold? Okay, because we know that when a particular engine runs, then in the intake manifold, vacuum is created. Okay, because of the suction stroke, low pressure environment is created in the intake manifold, that is the vacuum. So vacuum will drag in basically, okay, or picks up the blow by gases from the crankcase, okay, then it supplies to the combustion chamber and burns it during normal combustion. Okay, so if it is a 4-stroke engine, then out of 4-stroke, only the suction stroke, during the suction stroke, the gases will be collected through this hose pipe and supplied to the intake manifold. Okay, so what happens is that these exhaust gases, which is incompletely burned hydrocarbon, some the products of combustion, okay, and some vapor of lubricating oil, vapor of lube oil, not very high, okay, not very high quantity, only the vapor which has been created because of the high pressure, those contents will be supplied to the combustion chamber and burnt it. And in this way, you can actually reduce the loss which is occurred because of the leakage, this blow by process. You can by now understand that the blow by is basically a loss phenomena which occurs in the engine. So by this positive crankcase ventilation, you actually reduce the loss of vapor in the combustion chamber. So you basically burn with the help of intake manifold, which actually picks up the gas and supplies to the combustion chamber. Hope I understood. Now, we cannot just supply the blow-by gases directly into the intake manifold. Why? Because engine runs at different speed, sorry, at a different speed and load. Speed and load of a particular engine, either you tell a petrol engine or a diesel engine, either an SI engine or CI engine, whatever may be the type of engine, speed and load condition may vary. Okay. So when speed and load condition varies, the manifold condition is also variable. Okay. So because of this variable manifold condition, there will be certain amount of issues will come, because of which you cannot just directly link a hose pipe from the crankcase to the manifold. I will discuss it one by one. Let us try to understand. So this is a type of PCV valve which is connected between the crankcase and the intake manifold. Okay, this side comes from the crankcase. This side comes from the crankcase, left hand side or bottom side, you can tell, and this side goes to the manifold. Okay, so with this connection, we supply the blow-by gases to the intake manifold. Okay, so there is a valve over here which is fitted. Okay, in this PCV valve, this particular you can tell this is a bob. Okay, in either side of the movement of this valve, okay, it can go either right side, it can go at the left side also. If it goes in the right side, then also it closes the valve. If it goes in the left hand side and pushes this particular uh, uh, portion, then also it can close the passage. Okay, so only when this particular bob comes somewhere in the middle of this particular region, then it is fully open. Okay, now why it is done? Let us try to understand. So engine first runs at idle condition. Idle condition means what? When you just start the engine. Okay, when you just start the engine, this is an idle condition. Also, you can pass through certain other engine processes which are called as warming up and low speed operation. Okay, so during idle, warm up and low speed operation, what happens is that engine runs at rich mixture. That is, everybody knows that engine has to run in the rich mixture to operate in this particular operating ranges. Okay, now at idle condition or warm up at low speed condition, you have low cylinder pressure inside the combustion chamber. Okay, the combustion chamber will have low cylinder pressure, and because of this, the blow by which will be coming to the crankcase will be slightly lesser. Okay, because of the low cylinder pressure. But during this idle condition and low speed condition, what happens is that your manifold pressure is very high. Okay, manifold pressure usually remains at a high condition when we operate at idle and low speed condition. So high manifold vacuum, why it creates? It's because you run in the engine in rich condition, and in rich condition, the quantity of air required inside the combustion chamber is very less. Rather, a little bit more fuel supply is required. Air supply requirement is less. So when air supply requirement is less, the mass flow rate of air reduces, then the pressure drop increases. Okay. So pressure drop increase means what? There will be high vacuum in the manifold. So in this high vacuum condition, if you directly connect a hose between the crankcase and the manifold, then what will happen? It will draw in very high, large number of air, large quantity of air through this PCV hose, and it will actually dilute the mixture inside the combustion chamber. It will rather make the charge much more lean. When it makes the charge much more lean, then it will disturb the idle and warm up and low speed condition. So you cannot directly link the pipe with the intake manifold. So what happens is that if you connect this hose, then it will draw more air and it will cause poor drivability. So in this condition, when there is very high vacuum, this particular bob moves towards the right hand side, because this side is the manifold side, this side is the manifold. Okay, so this partially closes, not fully closes the passage, partially closes the passage between the bob and the manifold, and a small quantity of flow by is allowed to pass through this valve and go to the intake manifold. Okay, so one condition is that if just think that there is no bob, so what will happen? Directly the gases will air will go. This directly this quantity of air will mix with the rich fuel air mixture inside the combustion chamber, disturb the engine operation. Why high quantity of air will go this side? Because vacuum is high. Okay, why vacuum is high? Because at low operating condition is low speed and warm up condition, you requirement of air is less through the main manifold. So through main manifold, the masses of air coming inside the combustion chamber will be less. Okay, so that is the reason why this bob is designed in such a way that when you operate the engine at low speed condition, the bob will actually partially close this passage and allow small amount of blow by gases to pass through the manifold and go inside the combustion chamber. Okay, so this is about how it operates at low speed condition. Okay, now let us come to the high speed condition, medium to high speed condition. So when engine operates from medium to high speed condition, what happens is that mass flow rate through the manifold increases. Okay, the mass flow rate through the manifold increases. The amount of mass passing through the manifold increases. Why? Because now you require to lean the engine operation, because engine is warmed up. Now whatever fuel quantity you supply to the engine, it will burn out, it will give power. So you can now supply more air through the main intake manifold inside the combustion chamber, so that you can run either a stoichiometric, close to stoichiometric, or maybe in the lean operating range, so that your fuel economy is good. Okay, so when the amount of mass supplied through the main manifold of the engine is higher, then what is happens? The manifold pressure reduces. Okay, so reduces means it is earlier case, in case of low load condition, it is much below the atmospheric condition. Now it is slightly below the atmospheric condition. Okay, that means what? The pressure drop. Okay, pressure drop uh, is adjusted in such a way that the uh, pressure inside the manifold is slightly, only slightly lesser than atmospheric condition. So that in that case, what happens is that in that case, the bob is slightly released. Okay, it is not dragged in the right hand side, is slightly released. When it is slightly released, the passage is fully open. Okay, the passage around this bob is fully open, and now from the crankcase, the entire quantity of blow by, whichever quantity it is coming, it can pass through. Okay, so the flow through the valve increases from 3 to 6 cubic meter per minute when you operate at medium to high load or high speed operation. Okay, so this is the scenario over here when the bob is slightly released and the passage gets opened up. Okay, in this way the PCV valve works. And finally, another safety provision is also there in this type of valve, is that when you do the cranking, okay, when you do the cranking in the engine, at that time what you supply heavy mixture of fuel and air through the intake manifold if it is an SI engine, and a very high quantity of air in case of diesel engine. So during this cranking operation, because of high pressurized air is being supplied to the intake manifold, the bob get pressed in the back side. Okay, so it is basically back locks. Okay, back locks the PCV valve. Why backlock the PCV valve? Because at this condition, that means at cranking condition, there is always a chance of backfire. Okay, there is, if there is backfire is occurring, that means fire is coming into the intake manifold. Then if it is widely open, then this fire can propagate through this passage to the crankcase, and crankcase can erupt, can burst out. Okay, so to safeguard the crankcase out of that, this valve is drawn back to this particular passage line and closes this particular passage line. Okay, so that means what? From the crankcase, blow-bys are not allowed to pass at this cranking condition when you have high pressure in the regular intake manifold. Okay, so it backseats, the PC valve backseats, and it disconnects the crankcase from creating any type of fire hazard. Okay, so this is the operation by which positive crankcase ventilation works. Hope everyone understood. Now let us move to evaporative emission control. Now, what is evaporative emission control? You see, fuel is basically a volatile substance. Okay, so fuel always has a tendency to get evaporated. Okay, if you notice, either in scooty or bike or maybe in car, okay, big car, the fuel tank is always tried to be kept far away from the engine. What is the reason behind that? The reason behind that is that engine, when it works at a very high temperature. Okay, engine works at a very high temperature. Now, if your fuel tank is closer to that of the engine, then the fuel tank will get heat from the engine. After getting the heat from the engine, fuel will try to get evaporated. Okay, this is one case. Another case is that you if you fix a engine in an automobile, then definitely you are trying to move with the automobile along with the fuel. So when an automobile moves, either it is a bike, scooty, or maybe truck, bus, car, whatever may be, always the fuel inside the tank has a sloshing. It's as if having a movement inside the tank. Because of this sloshing and movement, turbulence created inside the fuel tank, and the tendency of fuel to get evaporated increases. One problem. Second problem is that if your engine is a carbureted engine, okay, then there will be a carburetor very close to the engine. And from the carburetor, we know from the design of a carburetor that there will be a float chamber, okay, where temporary small quantity of fuel will be stored. Okay, now if it is closer to the engine, it is exposed to the heat of the engine. When it is exposed to the heat of the engine, there also fuel has a tendency to vaporize. Now more and more fuel get vaporized. First thing is that it is a loss for you, because fuel vapor is directly going to the atmosphere. If it gets a chance, if you open the fuel tank to refueling, or if there is any leakage, if there is any passage from the container to the atmosphere, then the vapors will pass. So it's a loss for you. First problem. Second problem is that this fuel vapor is a vaporized hydrocarbon. So when this vaporized hydrocarbon is coming into the atmosphere, sorry, it will create pollution. Okay, so to safeguard this, or to save your fuel, as well as to save the environment from these losses, what it is done, there is a charcoal canister is fitted between the fuel lines. Okay, so what it does, okay, so this charcoal canister actually stores the fuel vapor in it, okay, in the by sticking the fuel on the surface of activated charcoal. Okay, so activated charcoal will be there, okay, which is basically porous in nature. There will be porous structure of the charcoal, high porosity. So what happens is that this, when the engine is shut off, then fuel vapor from the fuel tank and the float valve from the carburetor engine is allowed to pass through this charcoal canister. Okay, so as you can see over here, this charcoal canister diagram we have shown here. So through this charcoal canister, okay, vapor from float bowl is coming if it's a carbureted engine. Apart from that, from fuel tank also the vapors are coming into it. Okay, now when the vapor is coming and storing it, it is basically sticking on the surface of the activated charcoal. Now when the engine starts, what happens is that there is a purging passage. You see there is a called purge valve. Okay, what is purge valve function? The function of the purge valve is that this particular valve is connected to the engine directly. So what happens is that basically it is connected to the engine manifold. Okay, so again the same technology which is we have used in the positive crankcase ventilation is also used here. During uh, suction stroke, there will be vapor, that means low pressure created in the intake manifold. Because of this low pressure, it will try to drag the air in this particular passage, and when it drags it, then it carries away the fuel vapor. The air carries away the fuel vapor and comes and mixed with the air in the intake manifold. Okay, so in this way, the vapor which has been stored in the charcoal is actually released and going to the intake manifold. The way by which the fuel vapor is storing inside the charcoal and again releasing from the uh, charcoal canister to the intake manifold is called as purging or and depurging of the fuel vapor. Okay, so when engine starts, fresh air is passed through the charcoal canister. Fuel vapor is picked up by this air and supplied to the engine through intake manifold. Okay, so that is the way by which evaporative emission is controlled in a carbureted engine. Now, if it is a fuel injection engine, what happens is that in case of fuel injection engine, we all know that in fuel injection engines, we do not have a float valve. Float valve is already always there in the carbureted type of engines. Okay. Fuel injected engines can be also SI type, spark ignition type, petrol type, where currently we are dealing with PFI engines, we are dealing with CRDI engines, MPFI engines, where fuel injection in the engines is done. Okay, so in those type of engine where you do not have the float valve, the connection becomes slightly simpler, because now the canister will be connected with the fuel tank only, not with the float valve. Okay, so there is only one passage of entry of the fuel vapor from the fuel tank. Okay, then what happens is that in if we talk about the uh, CI engines, okay, what happens is that, or the diesel engines, from the float chamber, fuel vapor will be supplied to the charcoal canister. Inside the charcoal canister, it will be stored. Okay, and then there will be another line through which it will move to the intake manifold. Okay, in between this, there will be a purge valve. Okay, from this purge valve, the uh, fuel vapor is allowed to pass through this particular passage and allowed to enter into the intake manifold. Now, there will also be a lambda sensor. As you can see over here, the first is fuel tank, second is control valve, third is charcoal canister, fourth is lambda sensor, five is the ECU. Okay, what is the function of lambda sensor? Lambda sensor is also basically a oxygen sensor. From this oxygen sensor, it will give signal to the ECU that the catalytic converter is activated or not. Okay, or the what is the temperature of the exhaust. Accordingly, the ECU will
Sir,
give
I want to
signal to the
ask a question, sir.
charcoal valve, control valve. Hello.
Sir, I want to ask a question, sir.
Can we discuss it towards the end? I'll give you some time.
Sure, sir. Sure, sir.
You note down the slide number. Okay. Okay. So rather than vacuum assisted, electronic purge control solenoid is also used. Okay. Now the ECU open the purge line once engine reaches to the normal operating condition. Okay, as I was discussing in the earlier slides, that at warm up condition and idling condition, generally engine runs at low pressure and temperature. So at that time, you do not require additional supply of the this one fuel vapor. Only during when engine runs in the normal operating conditions, at that time we require this purge valve to operate and supply the fuel vapor into the intake manifold of the engine. So this is how a fuel injected engines works. The evaporating emission control works in the fuel injected engine. Then we come to the air pump. So when engine burns a particular fuel, it may create hydrocarbon and carbon monoxide emission. Hydrocarbon and carbon monoxide emission. So what is the function of the air pump? The function of the air pump is to supply additional air outside the combustion chamber to burn the hydrocarbon and carbon monoxide and to form carbon dioxide and H2O. Okay, so as you can see in this particular diagram, there is an air pump fitted over here, and this air pump is run with the help of a belt from the engine. Okay, so belt driven air pump is used. So this air pump pressurizes the air and supplies into the exhaust manifold. Now this air pump operation for engine operating condition is also different for different cases. As we know, when the engine is cold, okay, when engine is cold, that means you are operating the idle condition or warm up condition or low speed condition. Then you're in the exhaust, you have hydrocarbon and carbon monoxide emission, and the air pump with the help of a air control valve, okay, and air switching valve, air control valve and air switching valve, air is supplied to the exhaust manifold. In the exhaust manifold, when the injectors, fuel injectors at which the air will be injected, they are basically placed in the opposite direction of the passage through which exhaust comes out. Okay, and they hits the exhaust gas and burns out basically hydrocarbon and carbon monoxide outside the combustion chamber and produces carbon dioxide and H2O. Now, in case of warmed up, this is good when you are operating at low speed and low load. At this low speed and low load, basically during warm up, idling, and the slow speed, you run with uh, rich air fuel mixture. Okay, so when you run with rich air fuel mixture, the exhaust, that means hydrocarbon and carbon monoxide, which is coming out, okay, is burned out with the help of the supply of air in the exhaust manifold. Okay, but when the engine is warmed up, okay, so at that time what happens is that the engine already gets lean mixture, as I was discussing earlier, that when engine runs at medium speed and condition and medium load condition, at this condition your air fuel mixture is close to stoichiometric or rather linear. So at this condition, if you supply the air directly again in the exhaust manifold, then what will happen? There will be an oxygen sensor present in the exhaust. Okay, it will get an information that there will be higher amount of oxygen is passing through the exhaust manifold. That means the mixture is very lean. So it will give ECM a signal that you supply more amount of fuel into the engine. So which is not required. If you supply more amount of fuel into the engine again, then it will actually make the mixture much more rich. Okay. So you do not again require the rich mixture in the combustion chamber, because again this will deteriorate the engine operation. So that is the reason why when engine speed and load increases, then ECM gives a signal to this particular air control valve as well as air switching valve, that you redirect, you close the check valve which is going, which is allowing the air to go to the exhaust manifold. Rather, you open the another check valve which is connected with the catalytic converter. Okay. In the catalytic converter, there are two stages. One is the reducing stage, another is oxidation stage. I am not going in detail more about the stages, because Professor Young One Min will going to discuss more details about the catalytic converter in the coming days. But one thing you try to understand, that there will be a oxidization zone in the catalytic converter, where basically hydrogen and carbon monoxide is burned out and gives you CO2 and H2O. So in this condition, if you have less amount of oxygen content, then this oxidation stage is not actually efficiently operating. So for this oxidation stage to be operating appropriately, you require the air to be directed to this particular catalytic converter after the reducing stage, before the oxidation stage, because reducing stage is kept on only for the NOx. To reduction of the NOx, this reducing stage is there. Oxidation stage is there for the carbon conversion of hydrocarbon and carbon monoxide. So that is the thing is mentioned over here. In warmed up engine, exhaust gas gets leaner and necessity of air in the exhaust is lesser. Okay. So in addition, if additionally more air is added in the exhaust, then oxygen sensor sends a signal to ECU, and ECU would permit to supply more fuel in the combustion chamber. When more fuel is supplied in the combustion chamber, it will result a very rich mixture, okay, which is not desired at this particular condition. And that is why it is warmed in warmed up engine, ECM switches the air to the catalytic converter before the oxidation stage for the participation of this particular air pump operation. Now another thing is there important, is that as you can see in this particular diagram, there is also a backfire control is also provided here. Backfire control is provided here. Okay. So there is an deceleration bypass valve, okay, which diverts the air, gas, the diverts air which will be passing. Okay. You see, when engine is operating in the cranking condition, then in the manifold vacuum there will be high manifold vacuum. From this high manifold vacuum, air will pass in this direction and close this valve. Okay. So that air which is air pump, from air pump which is the air which is supposed to come in this particular direction and come to the manifold, is stopped here with the help of this bidirectional valve. Okay. So this bidirectional valve is also required to safeguard the engine from backfire. Okay. So now, yeah, any question, please?
Sir,
Yeah, please tell.
sir, actually, all these emission systems are only for petrol engine, yeah, for sir diesel engine also, sir.
Both type of engines, both petrol engines and diesel engines.
But sir, diesel engine, diesel is not that much volatile as compared to sir petrol. So means charcoal canister is also present in diesel engine, sir. I have seen the charcoal canister in some petrol engines in my bike also, sir. But
Diesel
means
diesel engine is also there, because in diesel engine, okay,
yes,
you
sir.
see, any type of hydrocarbon fuel is a volatile in nature. Okay, or maybe its density is slightly higher or lesser, but fuel vapor is definitely going to produce. Okay, so to restrict the fuel vapor and to safeguard your money, okay, the fuel canister is required. May not be fitted in all the cars, but whenever you are operating in a high range car, then definitely you require a canister. Yes, as you told, the charcoal canister is required in petrol engine more specifically, but it is not that, it is not required in case of diesel engine, or more specifically, if I tell that, fuel injected engines.
Got your point, sir. Thank you, sir.
Yeah. Any further question, please? So, in summary, what we have learned today, today we have learned about the positive crankcase ventilation. Okay, in positive crankcase ventilation, there will be some leakage of blow by gases which is passing between the piston and cylinder, which may create problem inside the combustion chamber, not only in the combustion chamber, in crankcase also. So in order to safeguard that, we require a positive crankcase ventilation valve, okay, which will be connecting with the intake manifold. This valve is a bidirectional valve. That means in up and down both sides, when it moves, it closes the passage, partially closes the passage, better if you see. But when it comes somewhere in the middle, this valve actually opens the entire passage to allow the blow by gases to pass in the intake manifold, and is supplied to the combustion chamber for direct burning of the gases. Okay, so this is about the positive crankcase ventilation valve, which is important emission control device. There is evaporative emission control system. It is used both in carbureted engines and fuel injected engines. This is because the fuel vapor which has been created not only in the fuel tank but also in the fuel float chamber, which is connected with a carbureted engine. So because of the engine heat, movement of the gases, the vapors are formed, and these vapors, if they release in the atmosphere, it is an pollution and also loss of your money. So it is, this gas is been stored in case of a charcoal canister more in during in the idle hours, means when you are not operating the engine, the vehicle, at that time it is allowed to, the gases are allowed to pass to store in the canister. Once the engine is started, then air is supplied, air is basically dragged into the through this particular canister, bring in um, air through this the fuel vapors which are stuck in the activated charcoal surface, what supplied into the intake manifold, burned it out, and basically safeguard the losses of fuel vapor and their consequent emission in the environment. Evaporative emission control devices are also used in fuel injected engines. There you do not have a float valve, but definitely you have a fuel tank. Okay, in the fuel tank, always there will be fuel vapor, less or more, the fuel vapor will be forming. Those fuel vapors are stored in the canister, and as per requirement, okay, especially medium to high speed engines, with the help of the control valve, the vapors are supplied into the intake manifold, burned it out in the combustion chamber, and the emission has been regulated. Finally, you have the air pump. In the air pump, air is basically supplied with the help of a pump into the exhaust manifold of an engine. If the engine is not warmed up, it is cooled, then the air is supplied to the exhaust manifold and burnt out the hydrocarbon and carbon monoxide into the exhaust manifold itself. Okay, at that time, the check valve which is connected to the exhaust manifold works. But when the engine operates at the high load, mid to high speed engines, at that time engine gets warmed up, and the exhaust gas slightly leaner. Okay, at that time you do not require the air to be supplied in the exhaust manifold. So this check valve closes, doesn't allow directly air to go to the exhaust manifold. Rather, it has been redirected and passed to the uh, catalytic converter, where you will have distinctly two stages. One is the reducing zone where NOx is reduced, and you have oxidation zone where hydrocarbon carbon monoxide is there. There is also one interesting thing is that this type of catalytic converter where you have reducing stage and oxidizing stage together. These are called as three-way catalytic converter, where three-way catalytic converters are usually used in petrol engines. But in case of diesel engines, only two-way catalytic converters are used, where you have only the oxidation zone, where hydrocarbon and carbon monoxide is burned out. In order to burn it out, additional amount of air supply is being done, which bypasses the exhaust manifold and supplied directly to the catalytic converter. So in this way, the emission control devices, these three emission control devices work. These are some references. If you are interested, you can follow these books. Okay, this will be give you much more details, brief idea about these particular emission control devices. Thank you.